In this section, we're going to consider a surface of revolution. So what a surface of revolution is something that you'd make using a lathe. So for example, suppose you had a curve looking something like this. If you rotated that around the x-axis, well, I'm just crap at drawing, sorry. I'm going to kind of cheat here. So for me, this looks like a pint glass, but the thing we're looking at is a solid. So it's a solid pint glass. It's a pint glass. There's no liquid. It's just made out of glass. Okay. And the question might be, okay, so this is between 2 points. Now here it's between 0 and this, but in general it'll be between A and B. And what you'll be rotating is a part of a graph, y equal to f of x. And the question is, if you know y equal to f of x, if you know A and B, can you calculate the volume of that so-called surface of revolution? And the answer is yes. Essentially what you do is you chop it up into loads of little pieces, into loads of little cylinders, and you add up all those little cylinders, pi r squared h. I think this should be possibly a dh, pi r squared delta h. And if you look back at what integration is, which you may not have learned much about with the way that the module last semester was really rushed, but basically integration is adding up infinitely many, infinitely small things. And so if you chop this up into loads of little cylinders, essentially infinitely many, and therefore each of their volumes will be infinitely small. To find the total volume, you will add up the infinitely small volumes of the infinitely many little cylinders. Okay, and it's given by this formula here. Now what we're going to be interested in is finding the center of gravity of these things. So for example, a very easy example, and I choose this example because I think I can draw it, would be a cone. Rotate a straight line around the x-axis like so, and you formed yourself a cone. And the question is, can we find the center of gravity of the cone? Now we're assuming uniform density here, and that means that by symmetry it has to be along this central axis. So the y-coordinate of the surface of revolution is definitely going to be 0. That's the first thing. And then the question is, how do you find the x-coordinate? Okay. So how do you find the center of gravity of the volume generated by rotating a curve? Now here I've drawn a line, but it could be a more complicated object about the x-axis between 2 points. Say again, I've chosen 0 here, but in general it's A and B. Again, if you want to look in the appendix, it turns out that the coordinates are, well, the y-coordinate of the center of gravity is 0, but the other was, it is the integral of xy squared over the integral of y squared. Usually you will have found the integral of pi y squared in the first part of the question, so you'll already know the integral of y squared. You'll have the bottom already, but then you have to calculate the integral of xy squared, and you can't kind of get it very easily. You just have to start all over again. So I think what we're going to do here is these formulas as well. Well, actually, this won't be given on the exam. So it says this formula will be given on the assessment paper, but you'll have to just know that y bar has to be 0 by symmetry. Okay. So we'll do this example here. I'm going to do 2 examples here. So suppose that the bounded area between the curve 2x squared plus 3, now we've already seen this in the previous video, have to sketch it. Okay, so suppose the bounded area between this curve, the x-axis, the coordinates x equals 0 and x equals 3 are rotated around the x-axis, determine the coordinates of the center of gravity. Now if you plot the points, as you did before, the only thing to look out for is that because you're rotating it, you're going to have to put the x-axis kind of centrally. What I mean by this is you have to put the x-axis here. Okay. Now if you look at the previous video, you can see what this thing looks like. I'm just going to do it kind of roughly here. Looks something like this. And maybe what I would do is I would put in the x equal to 3 into this and find that that's 21. So this goes up to kind of 21. Okay. I will rotate it now around the x-axis by kind of drawing it symmetrically. I'm very crap at drawing. So there we go. So this looks like a kind of a vase, but not a vase you can put any flowers in because it's solid. Okay. So this is if you plotted the points, you know, x equal to 0, x equal to 1, x equal to 2, x equal to 3, substitute those into this, find the y coordinates, plot the points, and then rotate this way you're getting. Okay. The question would say that you would get, first it would say sketch it, which we've done, then it would actually ask you to find the volume. Now we'll actually, oddly enough, do the volume down here, because this question is in funny order. It's going to leave a remark. So this is just for me to change this question. It's kind of old-fashioned. Okay, so let's find the volume of this thing. So we know that the volume is equal to the integral from 0 to 3 pi y squared, 2x squared plus 3 all squared. Now, if you were faced with this question straight off the bat, we've done something very similar in a previous video. This cannot be integrated term by term because it's not actually a sum because of the square. What you have to do is carefully multiply out 2x squared plus 3 all squared first. And if you do that carefully, now you can fix the pi alright, that's a constant. You have the integral from 0 to 3. Multiply this out carefully, you'll get 4x to the 4 plus 12x squared plus 9. This needs a manipulation, you have to multiply it out. And so now we will, what will we do? We will integrate this term by term. Fix the 4. Antiderivative of x to the 4 is x to the 5 over 5. Plus fix the 12. The antiderivative of x squared is x cubed over 3. Plus the antiderivative of 9 is 9x. And now finally this time, I know that if I substitute in the 0, I'll get 0 to the 5, which is 0, 0 cubed, which is 0, and 9 by 0, which is 0. So there's no real point substituting that in. If this was a cos x or an e to the x, it's a different story, but it isn't. So I'm just going to substitute in the top limit. So 4 fifths 3 to the 5 plus 12 thirds 3 cubed plus 9 by 3. And I'm just going to say, now the pi is out there, I'm just going to say minus 0, because I know it's going to give me a 0. Substitute in the 3, and let's see what we get. We had I think we had the same integral in the previous question. 4 fifths by 3 to the 5. 12 over 3 is 4 by 27 plus 27. 1647 over 5 by pi. If you want to approximate that, you can do so to 4 significant figures. It's coming out at 1035. There's no question of, there's no units here, so I can't say that it's meters cubed or anything like it. Okay, so that would be the volume. That would be the first part of the question in the type of thing that I'll give you. The second thing then would be to calculate the center of gravity. Now you know that the y coordinate of the center of gravity by symmetry, it has to be along here, so the y coordinate has to be 0, so that's done. And now what we want to look at is looking at from the formula that the x coordinate of the center of gravity is the integral of x y squared dx over the integral of y squared. The integral of y squared we have essentially got already from the volume. Just forget about the pi here, and this is the integral of y squared. So the bottom of this thing is 1647 over 5. That's fine. We need to look at the integral of xy squared though. So we're looking at the integral from 0 to 3 of x by y squared, which is 2x squared plus 3 all squared. Okay. Now here's just a small comment about a substitution, but we should look for a manipulation before a substitution, so we must multiply out the integrand carefully. If you do that, if you multiply 2x squared plus 3 all squared out carefully, you will get 4x to the 4 plus 12x squared plus 9. We did this in the previous video. Multiply 2x squared plus 3 by 2x squared plus 3, you'll get this. And now x times this, all of them get multiplied by x. So you get 4x to the 5 plus 12x cubed plus 9x. Okay, so this is xy squared. So what we have to do is integrate this from 0 to 3. Sorry about the dog. Okay, so this can be anti-differentiated term by term. Fix the 4, antiderivative of x to the 5 is x to the 6 over 6. Fix the 12, antiderivative x cubed is x to the 4 over 4. Fix the 9, and now consider that x is the same as x to the 1. Okay, x squared over 2, and we're going from 0 to 3. Now similarly to before, I know when I substitute in that 0, I get 0 to the 6, 0 to the 4, and 0 squared. That's all just giving me 0, so there's no real point substituting that in. Look out for e to the x, e to the 0 is 1, and look out for cos of x, cos of 0 is 1. And anyway, substitute in this top limit. I get 4 over 6, 3 to the power of 6, plus 12 over 4. Now, I could be simplifying these. 12 over 4 is 3, but if I'm banging them into the calculator, it's not really totally necessary. Plus 9 over 2, 3 squared. Take away, if you substitute in that 0, you get out 0. Substitute in this 3, which is the top limit. Bang it into the calculator. I get 2/3 by 3 to the 6. Plus 3 by 3 to the 4 plus 9 over 2 times 9. And I'm coming out with a number here, 1539 over 2. And now I should have enough to write down the x coordinate. So the x coordinate of the center of gravity, the same as the centroid under certain conditions, is integral of xy squared dx over integral of y squared dx. Integral of xy squared we just found is 1539 over 2. Integral of y squared is this 1647 over 5. And we'll approximate this to 4 significant figures. And I'm getting 2.336. Now the answer, so we put that now in the picture. Now, because the volume isn't drawn to scale, you don't see that how fat this thing is at the bottom, because it grows quite quickly. So a lot of the volume is down here. So I mean, if I'm kind of roughly saying 0, 1, 2, 3. Actually, that looks correct, actually. So this is the x coordinate, which maybe just two significant figures is 2.3, and the y coordinate is 0. So the 4 parts of this question is sketch the volume, then find the volume using a formula, then find the x coordinate, and you need to know that the y coordinate is 0, and then indicate it on your sketch.